So good evening everyone, welcome back to the session. So just type in the chat box, is the audio and video fine to all of you? Yeah, good evening all of you. So just confirm the audio and video. Good evening. I hope you have done fluid mechanics today, right? Sandeep sir might have taken you to the XC PYQs again, some nice PYQs. So we'll continue with the math session again, okay? And then we'll look forward in solving so many questions and all like that, okay? Yeah, good evening. Audio video clear? Okay. So let's start. This is part 2 of XC PYQs again. So we have reached till this point. So XCA again today, and of course there's slight change in the timing. And tomorrow again you have fluid mechanics, the last session by Sandeep sir, and again maths also. I'll take one more last session tomorrow. That's for the PYQs. Then in the next continuation week, like let's say till here, if it's Sunday, correct na? Today is like Wednesday, Thursday, Friday, Saturday, Sunday. Yeah, this is Saturday and Sunday. So once again from Monday we'll solve the अभ्यास sessions. अपने सेशन कब तक खत्म होगा? 12 बजे तक. आप लोग बताइए कब तक चाहिए? Revision of last year, sir. Can I please get PDF of it request? I'll try Sohali. Ansai. Okay. So chalo. Then let's. And this is the Telegram code. Okay, so the QR code which you can join to the channel so that you can ask any doubts and all in this channel definitely. So let's start with this question. MCQ 2020 में दिया था 2 marks के लिए. So solution. Let's see. Let A be a 3 by 3 matrix such that given A 3 by 3 and A square is equal to A. Okay, so A square is equal to A. So can anyone mention the name of this type of matrix? If A square is same as A, then what is that matrix called? Anyone of you? There is some name for this condition. If you multiply a matrix with itself, then again you will get the same matrix. What is it called? क्योंकि इस क्वेश्चन में लकीली दिया था कि A square is equal to A, but if they mention it using that word, if A is a 3 by 3 matrix such that A is this particular matrix, then which of the options is correct? It is idempotent, correct? It is idempotent, obviously. So A square is equal to A is an idempotent matrix. Idempotent matrix. Do you know what is the meaning of this in reality? Okay, idempotent matrix is A square is equal to A, fine. But do you know what is the actual meaning of this matrix? Let's say if I tell it I have a matrix which is idempotent, okay, then what does it mean is, if you apply this matrix on any vector, the matrix is effective only once, okay? Means what A can do, like capital A, if you apply it on a vector, for example, you take any vector, let's say 3 by 3, so you take any x vector which is of size 3 by 1 and you apply A, you will get some y vector which is again 3 by 1, okay? Then definitely you apply A one more time, this y won't change, like A square x, A cube x, A power 4x, whatever, how many times you keep applying A, it can impact the vector only once, okay? Now definitely this, depending on the matrix and this vector, this y gets rotated from x and also it stretches or shortens different geometries, okay? So anyway, if this is the case, then let's see what they are asking you. First option, A is the identity matrix or the zero matrix, need not be, for example, okay? So this need not be the case. A need not be 0 or idempotent actually, okay? Then the determinant of A power 4 is either 0 or 1. So first of all, if you see, since A square is equal to A, you take determinant on both sides. So det A square is equal to det A, and det of A power n can be written as det A whole power n. So this first term can be written as det A whole square, and if you bring this minus det A to the left hand side, so this is equal to 0. So det A times det A minus 1 should be 0, and you know the determinant of an idempotent matrix can be either 0 or 1. So these are the two possibilities that this determinant can be either 0 or 1 definitely here, okay? So it is, and obviously if this is 0 or 1, then det of A power 4, you know, so therefore det A power 4 is same as det A whole power 4, which can be 0 power 4 0 or 1 power 4 1. So idempotent matrix or any higher power of idempotent matrix will always have either 0 det or det of 1 actually, okay? It is necessary that the determinant is of A power 4 is either 0 or 1. The rank of A is 3, need not be, because if the determinant of A can be 0, then there can exist idempotent matrices with less rank, okay? Like if I choose a matrix such that the det is 0, then definitely rank won't be 3, it will be less than 3. Okay, it can be 2 or 1 depending on the elements you take. So this statement need not be correct. A has one imaginary eigenvalue. No, because I'll tell you why. If determinant is 0, for example, okay, which tells you the other two eigenvalues. Okay, like for example, if you see A has one imaginary eigenvalue. So if you have one imaginary eigenvalue, let's say A plus IB, then definitely, you know, it's a 3 by 3 matrix. You should have conjugate pairs. Okay, A plus IB and A minus IB. And if lambda 3 is equal to 0, for example, then there exist certain properties for this matrix such that the combination of two, like you can see, the product of this and this is 0, but having determinant 1 is not always necessary when you have the complex combinations. So this one imaginary value need not be always 2. Okay, because whenever you generate an idempotent matrix, generally you'll have a real matrices, of course. Okay, I mean the real eigenvalues actually. So this second statement is the statement which has to be definitely correct. Got it? Yes. Is this question clear to all of you? And this is the logic behind it. Okay, so please type in the chat box. Is this clear? Come on guys, every one of you, type it in the chat box. Is this okay to all? That A should be either 0 or 1 is the mandatory option that should happen. Chalo. So let's see the next question. Players A and B take turns to throw a fair dice with 6 faces. If A is the first player to throw, then the probability of B being the first one to get a 6 is dash. Okay, these guys are maybe sitting happily at lockdown so that they are playing the dice game. Okay, so 2020 again XE 2 marks. So let's see, A and B takes turns to throw a fair die. What does it mean? Let's say for example, if A throws it, okay, if he gets a 6, then that's all. Okay, but if A do not get a 6, again B throws it. Then if B gets a 6, that's all, it's done. So first of all, whenever the 6 comes for the first time, then the game is closed. Okay, so let's see, players A and B. A and B started the game, okay, to throw a fair dice with 6 faces. If A is the first person to begin, okay, so A begins the game. A begins the game, okay, to throw, then the probability of B getting the first one to get a 6. So let's see, what is the probability of getting a 6? 1 by 6, correct? So probability of getting a 6 in a die is 1 by 6. It's a fair die. Now let's see, when A starts the game, the probability of B getting the first one to get a 6. So when A starts the game, A should not get a 6 and B should get a 6, correct? Yes or no? Then in this case, you'll see A is not getting the 6. If A is starting the game, then definitely A should not get a 6 and then B gets a 6. Then B is the first one to get a 6. This is one case. Or probability of A did not get a 6 and B did not get a 6. Again A did not get a 6 and then B got a 6. This is one way. Okay. Next, this game can go on up to infinite times. So A do not get a 6, B do not get, A do not get again, B also do not get again, then A do not get again, and then finally B got a 6. Okay, so this is also one more case. So if you keep doing all this stuff, then getting 6 in any of these events is purely independent, correct? Yes or no? Can you do it by Bayes theorem? Need not be Bayes theorem because there is nothing fixed condition which is given. Okay, so you can see probability of B getting 6. Okay, so probability of, you can say required probability is equal to required probability is equal to, so this sequence goes on, and each of the time, every time that either A or B roll a die, it's independent. Okay, it's not like since A did not get a 6, the die won't think that I should not turn out 6. Okay, so each and every event is independent, which means this can be written as probability of A not getting a 6 into probability of B getting a 6 plus probability of A not getting a 6 into probability of B not getting 6 into this. So A square P of B complement into P of B getting a 6 plus similarly P of A complement whole cube, P of B complement whole square into P of B, and so on. This goes on. Now, if either A throws it or B throws it, the probability that you won't get a 6 is 5 by 6, and the probability you'll get a 6 is 1 by 6, which means this term turns out to be probability of not getting 6 here, 5 by 6 into probability of getting 6 is 1 by 6, plus these two probabilities are same. Probability of A not getting a 6 is same as probability of B not getting a 6, because in both their hands there is a fair die whenever their turn comes up. So this is 5 by 6 whole cube into this P of B, 1 by 6. Next, this term would be 5 by 6 whole power 5 into 1 by 6, plus, and so on. This is the actual answer in this case. Okay, did you all understand this? I'll do the simplification, but did you all understand the logic? Why we followed this logic? If A gets a 6, then B can't throw, then how is it independent? Then the game will stop, right? And we are looking at the probability of B getting the first 6. Understood? We are looking at the case of B getting the first 6. If A gets the first 6, then game ends. That's all. There's nothing. Then we don't get this probability. Okay, we get the probability of A winning the game. Clear? It's okay to all of you? Yeah, I'll repeat. See, first of all, the die is in initially hands of A. Okay, so when A rolls, you should not get a 6, and then when B rolls, you should get a 6. This is the way in which B gets the first 6. Or first, when A throws it, you don't get a 6, B also don't get a 6, again A doesn't get a 6, B got a 6 then. Okay, then also this is the case which favors B getting the first 6. Similarly this. So likewise, it can go up to a very infinite number of trials actually. Okay, so now if you see, all these events are independent. So for independent events, for A comma B being independent, P of A intersection B is same as P of A into P of B actually here. Okay, so then you can see P of A, you can split all these events in these multiplications, but probability of A not getting 6 or B not getting a 6 is same. Okay, so therefore, so intersection means or and, okay, and is for intersection. So that's why your multiplication. So all these terms can be replaced with numbers. Probability of not getting a 6 is 5 by 6, and probability of getting a 6 is 1 by 6. Okay, so therefore, probability of B to get first 6 is equal to, now from these terms, if you take this 5 by 6 into 1 by 6 common, 5 by 6 into 1 by 6, if you take common, then you have 1 plus 5 by 6 whole square plus 5 by 6 whole power 4 plus 5 by 6 whole power 6 and so on till infinity. Okay, so this is what you get. Now clearly this is a geometric progression. Yes, you know, like if you have geometric progressions, AR square, AR cube, and so on like this. Okay, so this is 1, then common ratio is 5 by 6 whole square, which is 25 by 36, and so on. So if you add for mod R less than 1, A plus AR square and so on infinity is equal to A by 1 minus R. Do you know this? If you have this series, then this expression turns out to be that value, A divided by 1 by R, sorry, A divided by 1 minus R. Yes? Okay, so therefore, see, ideally if R is more than 1 even, okay, then sum of n terms of a GP is A into 1 minus R power n by 1 minus R, and when R is less than 1 and n tends to infinity, so the expression turns out to be this. So if you substitute here 5 by 36, this geometric progression A by 1 minus R, which is 25 by 36. Okay, so 5 by 36 into 36 by 11. So 5 by 11 is the answer. So if A starts the game, then the probability that B wins the game or B gets the first 6 is 5 by 11 actually. Okay, so therefore, sorry, it's okay. So probability of B to get first 6 is equal to 5 by 11. Okay, so it should be there in somewhere in the answer. So round off to 2 decimal places. Okay, so 5, oh okay, let me open the calculator. So 5 by 11, okay, 5 by 11, so 0.45. That's all. Okay, so how I come to know that I'll have infinite tiles? Because see, it's not like B always wins in the first attempt, okay, or B always wins in the second attempt. When you keep rolling a die, it can happen any number of takes. Okay, like let's say they started throwing, like in Ludo, you know, if you play Ludo for example, many of the times your coin will be near the home, but you need just a 1, okay, to enter. But many times you keep trying, you won't get 1, okay, so then your tiles can go up to infinity. But luckily, of course, in reality at some point you'll get 1 and you will enter. But probability of B is equal to 1 minus P probability of B not getting, yeah, correct. This is a very straightforward approach, correct? Or you can find the winning of A, that's also can be done. Okay, one of them has to win, so probability of B winning the game is nothing but 1 minus probability of A winning the game. So you can calculate probability of A. Okay, then in that case the GP turns out to be 1 by 6 plus 5 by 6 whole square into 1 by 6 plus 5 by 6 whole power 4 into 1 by 6 and so on. This is the probability of A winning the game. Okay, and then you can subtract it from 1, you will get probability of B winning the game. This answer is 6 by 11 actually, if you can check. Okay, so 0.45 is the actual answer. Is this question clearly understandable to all of you? Yes? Are you all okay with this question? Do you all understand this? Yeah, I want everyone to respond in the chat box. Okay, so chalo, let's move. See, I'll tell you one thing guys, whoever attends this session definitely will feel benefit out of it. Okay, trust me, because like even during the ME Maha and all, whoever has put consistent efforts, they would have definitely done well in the exam. Okay, so please keep yourself in the loop in this 7-10 days, at least in the 10 days whatever is remaining, and please try to be attentive. That could definitely help you, because at this point we don't want to waste time. Okay, I'm not deriving anything to show you this, that and all. Only episode rule, since you have asked yesterday, I have shown you how that comes up. Okay, but otherwise I'll save the time, so don't worry. Oh, one question is missed in between. Yeah, okay, this one. So let's see, let X be the Poisson random variable with parameter lambda is equal to 1. Okay, so the mean parameter lambda is 1. Then the probability of 2 less than or equal to X less than or equal to 4 equals. So very simple, 1 mark question, of course. So X is a Poisson random variable. So lambda is equal to 1. So what of P of X is equal to, for example, T e power minus T or e power minus lambda into lambda power T by T factorial, correct? So this is what you have actually. If T is some number, then where T belongs to Z plus. So then let's see, because Poisson random variable is a discrete random variable, so clearly P of 2 less than or equal to X less than or equal to 4 is equal to P of X is equal to 2 plus P of X is equal to 3 plus P of X is equal to 4, because you know this Poisson random variable is basically the discrete random variable, and the variable depends, or the value of X means if you take X as the random variable, then the value of X depends on the time interval. Like I'll give you some example. Normally if you're doing this industrial engineering, okay, or operations research for example, and if you are working out queuing theory, okay, you'll see that the service rate is Poisson distributed actually. Okay, so yeah, of course the service rate is Poisson distributed. The reason is, I'll give you one simple example. Let's say I'm working as a receptionist, okay, for example in some hotel, okay, and let X is the number of calls I get, for example. Now if I take my time interval only for 5 minutes, then the value of X can be small, but if I take my time interval to be some say it's like 20-30 minutes, then definitely x value is high. Okay, so that's why these are the variables where a level Poisson service exponential. Is it a level is normally distributed? No. If you draw the Kendall's notation, in the Kendall's notation, lambda mu, correct. 2 a level is Poisson, of course, correct. Gate mechanical में around 65 marks है, कुछ हो सकता है, पक्का हो सकता है, कुमार, no issues. Okay, so let's see in this case e power minus lambda into lambda square by 2 factorial plus e power minus lambda cube by 3 factorial plus e power minus lambda power 4 by 4 factorial. Okay, and this parameter is given as lambda is equal to 1. So therefore for lambda is equal to 1, e power minus 1 you can take common, 1 square, 1 cube, 1 power 4, all these are same, 1 by 2, 1 by 3 factorial, 1 by 4 factorial is 24. So if you simplify e power minus 1 by 24, if you take common, then here you have 12, 12 plus 4, 16, 16 plus 1, 17. So 17 by 24 times e would be the required probability actually in this case. Okay, yeah, of course, even in PSUs you have a very big chance if your marks are above 65, definitely. Okay, because for above 65 your rank would be definitely below 500, and yeah, you'll get definitely some PSUs. Okay, but if you want to go to things like ONGC, ISRO, okay, then you have to write the exams. Okay, again BRC has also this option of gate. Fine, so what is the answer? 17 by 24, E is the correct answer, B is the correct answer. Okay, a very straightforward question, 1 mark is what you get if you solve this. Okay, so then let's see, for the series sigma n equal to 1 to infinity x plus 1 whole power n by n into 2 power n minus infinity less than x less than, we'll do one thing, I'll push this sequence and series towards the last. Okay, so then we'll stop this question for now and we'll move forward to the other questions, because at the end I want to take some questions of partial differential equations and sequence and series. Okay, in sequence and series I want to teach you integral test, then Cauchy's ratio test, and also Cauchy's test, and also D'Alembert's ratio test. Okay, so we'll do that. So for now let's solve this. Solution: let y1 of x and y2 of x be two linearly independent solutions of the given differential equation. So this is the Cauchy, sorry, not Cauchy, I mean Euler-Cauchy equations. So given dE is x square d square y by dx square plus x dy by dx minus 4y is equal to 0. So let's make this substitution. X is equal to e power x, and this gives you x d by dx operates as d, where d is d by dz actually. Okay, so d is d by dz. Now let's see, d into d minus 1 plus d minus 4 operating on y is equal to 0. So d square minus d plus d, so minus d and plus d gets cancelled. So in probability, what about the value of p of 2 less than 3? P of 2 less than 3, what does that mean? Didn't get you. X less than 3 is what you want. Then p of x equal to 0, x equal to 1, x equal to 2. That's all. Okay, so we should consider these three cases and sum up the probabilities if p of x less than 3 has to be known. Okay, so let's see, d square minus d plus d gets cancelled, then minus 4 operating on y is equal to 0. So this gives you y is equal to c1 e power 2z plus c2 e power minus 2z, so which is c1 x square plus c2 by x square. So this is the solution. So what are the linear solutions now? Let's see, if y1 of x is equal to x square, so y1 of x is equal to x square. So these are the two linearly independent solutions, x square into 1 by x square. Okay, y2 of x is equal to 1 upon x square. Then limit x tends to infinity, y2 of x. Sorry, sir, can you please explain about this topic a little bit? This topic, yeah, I can explain you, no issues. Okay, this topic is what you want ना, Adarsh, I'll explain, no issue. Okay, Euler-Cauchy equations क्योंकि काफी बार से आते हैं, so I'll do that. सर आप तो ऑलराउंडर हो सर, आपके बैच लॉन्च करो जिसमें सारे सब्जेक्ट सिर्फ आप ही पढ़ा है. हाउ कैन आई टीच ऑल द सब्जेक्ट्स मैन? आई कांट, टू बी फ्रैंक. ओके, value of p of 2 less than x less than 3, 0, because x is discrete. Okay, so x can take only like the integer values, and since there is no integer between 2 and 3, then it is 0 definitely. Okay. Okay, I'll teach you Euler-Cauchy equation, but just if you look at this, is this okay to all of you? Is this okay to all? y2 of x is equal to 1 by x square. See, Mr. Tensor, I'm good at tensor calculus, but I love to see your name as Mr. Tensor. Firstly, if I teach all the subjects, then definitely, you know, you will be at the loss, because obviously I know I can't do justification for the 100% syllabus of mechanical engineering. Okay, for XE I can do maths, fluids, thermal, I'll do 110% justice, I know this, but for mechanical I can't teach all the subjects. I can teach only the thermal module, like the thermo, applied thermo, fluid, heat transfer, these subjects, and maths of course. Okay, so we all are a team. Okay, and our team together can do good things definitely. Okay, because every faculty is the best in their own domain. So definitely, if see, for example, if I start teaching, for example, material science, you will just hate me literally. Okay, because I myself don't know many points in material science. Okay, so that's why I'll honestly tell you, when it's a collective effort, normally not only here, you play cricket, okay, you don't expect a single guy to bat, bowl, keep, field, everything, right? So it's a team, same thing. There is only one game that you should play alone. You know what? Can anyone tell me? There is only one game which only you should play it. Can anyone tell me? Do you anyone of you know? लूडो. अरे लूडो में 200 बंदों को नेसेसिटी है ना, कम से कम कंप्यूटर पे चाहिए. चेस, एग्जाम गेम, सुडोकू. Exactly, our own life. Okay, so you should play your own life, nobody else can play it. Clear? Exam is सब छोटा मोटा चीज है, but normally when you take a decision, a call in your life, that's what it impacts. Okay, so your life is the only game which you should play alone, and make sure the others interference is very less. I'll tell you one, because I generally don't discuss my personal things in the class, I keep on teaching the stuff, but I'll tell you one simple thing. I'll tell you honestly what has happened in my life. Initially, own life is complicated answer. So initially I went to IIT Madras. Okay, after my BTech, I'm a 2017 passed out. Okay, some 7 years or maybe 8 years by now, I don't know. So I have passed BTech. Immediately I got admitted to the same year, I got admission to IIT Madras MTech. Okay, so I started my MTech, I have upgraded to PhD, but then things all of a sudden changed. A lot of stuff has changed, and I have to come as a dropout of IIT Madras. Okay, so when I came out, the next almost 2.5 years I came out. Okay, like 2019 December I came out, and then till 2021 December, you can take almost like 2 years, couple of years. That was like the hardest phase. Okay, so imagine many of my friends who were very close to me, who knows my skills and all, they used to suggest me like, why are you wasting time thinking that you have done BTech in mechanical, you'll do mechanical jobs? Why are you such a putting a preference on a small thing? You go to IT, you can earn so much money, all this stuff. They used to, this colorful guys, they used to post some colorful destination photos and all, and to be frank, I used to curse myself for choosing mechanical. But then when I got selected in the HPCL is the first PSU that I cleared in my life. Then after there's BRC, then after there's ISRO. So there are other PSU exams which I have cleared. So when I cleared HPCL, that's the first exam that I have cleared in my life. The exam in the sense like the complete process, okay, till the final selection. So that's the first thing. It happened almost like 3.5 years ago by now. So then all the people who suggested me to go to IT or change my domain, or people who are dumber than you are getting more money or doing better stuff. So when they have who all have suggested me these things, they came to me. At least out of these suggested people, I have a very close friend with whom I was a friend with since the kindergarten almost. Okay, so that guy and me used to go to school together. He's a neighbor of us. So that guy came to me and told, obviously it's a French language, I cannot use it now, but he told me, you have proven all of us wrong. Okay, that's what he told me. And that day you feel like you win everything. So in your life, the decisions or the thoughts given by others. You should listen them, but it's not you blindly follow it. You should iterate yourself. Okay. I'll show you some maths today, the real life maths. What happens if you choose GATE as your perfect career now? Okay, nowadays. I'll show you, because as per my idea, many of you are from mechanical or civil or some other core branches at least. So I'll show you one simple math which can give you a very good understanding about things. Okay, chalo. Let's continue this question. I'll teach Euler-Cauchy equation, but first let's see here. So this is the function you have. So limit x tends to infinity y2 of x. So now you tell me, if I apply a very large value for this, so this would be 0 definitely. Okay, so because 1 divided by what your gate rank in first attempt. At that time it's almost like 1700 odd. Okay, but later eventually I did better. Okay, so let's see limit, because at that time number of people in mechanical were very huge. Like when I wrote for the first time, 2017 gate is the first attempt for me, because at that time third years don't have a chance. Luckily you guys have attempt in third year, but at that time we used to write only in the final year. So at that time the number of candidates in mechanical was like around 1.4 lakh or something odd. 2018 or 19 is the peak. 1.6 or 1.7 lakh students in mechanical has written the exam, but today it fell down to 55 to 60,000 somewhere. Okay, so no issues. Getting things is easy for us now. Why did you leave BRC? It's a long story, I'll tell you sometime later. Okay, so chalo, this value is 0. Limit x tends to infinity y2 of x is 0. So coming to Euler-Cauchy equations, I'll tell you, see, which is again a very common topic. Euler-Cauchy equations. So if you see, normally we have the differential forms, okay, and this is a higher order differential equation, a linear differential equation, but with a variable coefficients. Like the coefficients of d square by dx square is x square, which is not a constant, it's a variable. Okay, similarly coefficient of dy by dx is x, which is also a variable. So it is basically a higher order linear ODE. Okay, ordinary differential equation, and in this case the functions whatever you have are of some specific form. Okay, like if you see the equations, the general form is x power n nth derivative of x plus some constant, say k1, x power n minus 1 into n minus 1th derivative of y by dx power n minus 1 plus k2 x power n minus 2 into n minus 2nd derivative of y by dx power n minus 2, and so on, plus kn into y is operating on some function x, let's say, where capital X is some function of x. Now I'll make the job easy for you, don't get panicked, but this is the general form. Okay, so let's say for example if you choose second order differential equation. Okay, so let's say x square is what you're starting. Even in exam they'll give only from x square, majority in gate exam, because if you start this equation from x cube, the auxiliary equation would be cubic equation. Okay, so solving cubic equations directly is not very simple, so they'll end up, like you can see all the PYQs, they have maximum x square d square y by dx square. Okay, so for n equal to 2, okay, so consider x square d square y by dx square plus x dy by dx plus y is equal to, or you can say k1, whatever, you put some numbers, k1 x dy by dx plus k2 into y is operating on this function x, let's say. Okay, then what we can do is, this can be written as x square d square by dx square plus k1 x d by dx plus k2 operating on y is equal to x. Correct? Now to simplify this x into d by dx, x square into d square by dx square, these combinations are manipulated a bit. Okay, and the perfect choice for this to solve is put x is equal to e power z. So obviously you'll get z is equal to ln x. Okay, now if you consider d by dx for example, okay, can I write d by dz as, this is derivative of d with respect to z of any function, but since z is depending on x, can I write this as d by dx into dx by dz. Can I write it this way? Yes or no? Everyone. This if I have, then using the chain rule or basically the basic manipulation, can I write this derivative as d by dx into dx by dz actually? Yes. And what would be dx by dz? Like you can check, if you differentiate this equation both sides, dz is equal to 1 by x dx. Okay, so which means this dx by dz, if I pull this dz here and shift the x to the left hand side, dx by dz, this term whatever you have is x actually, correct? Dx by dz is x. So therefore d by dz, the derivative of anything with respect to z is same as x into the derivative of the same function with respect to x. So this is how you can replace this x into d by dx as this value, and normally I denote it with capital D, the derivative with respect to z. That's how this manipulation happens in case of Euler-Cauchy equations. Got it? Yes? No? Something? Happy? Not happy? Okay, so that's the reason why in all Euler-Cauchy equations we replace d1 से denote करते हैं इसको, anything like it's just a notation. Okay, normally in all standard books they follow d, so I'm putting d, that's all. Okay, normally if you like generally see the book which I follow for differential equations is Ordinary Differential Equations by Piskunov. Okay, PSUs, he's a Chinese author, but this guy has written tremendous books actually. So similarly, if you try to figure it out, okay, using the same chain rule, x square into d square by dx square, you will see this becomes d by dz into d by dz minus 1 is what you will get. Okay, you can apply the chain rule twice. It's slightly lengthy, so that's why I'm just showing it like this, but it's very simple, not very tough as you see. Like maybe if I can show you, x square into d by dx of d by dx. Okay, and this is x square into d by dx of this d by dx. You can see d by dx can be written as 1 by x into d by dz. Okay, so 1 by x into d upon dz. So again differentiating sum of two functions, then you'll get two terms. I mean this is product of two functions, so when you differentiate you'll get plus 1. All these derivatives if you substitute, you'll finally end up with capital D into d minus 1. Okay, similarly for the third derivative, if you have x cube into d cube by dx cube, if you have, that can be written as d into d minus 1 into d minus 2, like that. So once you do this stuff, this if you simplify you will get this. So once you replace this, you call this equation 1. Okay, then this equation 1 implies, now this can be replaced with d of d minus 1 plus k1 into d plus k2 operating on y is equal to x actually. Okay, now one major drastic change that happened because of this substitution, this is a differential equation, but in this differential equation, so you can see this is f of d operating on y is equal to x, the normal standard form of your higher order differential equation. But this f of d has a specialty that the coefficients of the differential terms are no more variables, they are just constants. Okay, and this differential equation is in terms of y and z actually. Okay, you can convert this capital X, function of x, in terms of z, because you have x is equal to e power z. So what are the function you have in terms of x, you can convert in terms of z. So this is a higher order differential equation in terms of y and z, but this differential coefficient has constant coefficients everywhere. Got it? Which is easy to solve. That's how I got converted in this question. If you see, these are variable coefficients, but after solving you got a constant coefficients function in terms of capital D. Okay, so that's the technique behind solving the Euler-Cauchy. Okay, fine, good enough. It's okay to all. Chalo, then let's move to, so definitely its value is 0. It's a 1 mark question, that's why it's very simple. So if you take for this type, can we calculate particular integral? Yeah, why not? See, you can calculate the particular integral. The particular integral will be in terms of z. Okay, then put back z is equal to ln x again in the final solution. Okay, like in mechanical there came a question, but that of course that's also a homogeneous question actually. Okay. Chalo. So this is ODE with constant coefficients. Okay. So let's solve this diagonalization question, 2019, 2 marks. It's a good question actually. So let's see. Solution. If Q is equal to 3, 2, 4, 2, 0, 2, 4, 2, 3 actually. Okay. So they have given you a matrix. Okay. So this is the matrix. And P is V1, V2, V3 is the matrix where V1, V2 and V3 are linearly independent eigenvectors of matrix Q. Okay. So this V1, V2, V3 are linearly independent eigenvectors of matrix Q. So P is equal to V1, V2, V3. Can someone tell me what is the order of this matrix, size of this matrix? Any one of you? Can someone tell me what is the size of that matrix? One by 3, is it? This is actually a 3 by 3 matrix. Okay, that's what I was telling you yesterday. It's not 1 by 3, it's 3 by 3 because when you calculate the eigenvectors of this matrix, V1 is, let's say, maybe x1, x2, x3. So V2, say y1, y2, y3, and V3 similarly z1, z2, z3. So these are the eigenvectors. Okay, so each element here means a 3 by 1 column. So 3 by 1, 3 by 1, 3 by 1. This P itself is a 3 by 3 matrix. Now it's given that all these 3 vectors are linearly independent. This implies that P is non-zero. So P inverse exists. That's what it means. Okay, because you know, if all the 3 rows of the matrix are linearly independent, then definitely rank is 3, which means determinant is non-zero. Okay, so P inverse will exist. That's the story that conveyed in the first 2 lines. Okay, so let's see the sum of absolute values of all the elements of the matrix P inverse QP. Okay, so let's consider P inverse QP. Okay, so what are the elements that you would get in this matrix? So let's see. First of all, this is a diagonalized form. Yes or no? Will you all agree? Correct. This matrix which is here is going to be diagonal matrix of lambda 1, lambda 2, lambda 3 from the concept of diagonalization. Like I have told you in the last class, we have solved one question in fact. So if you have a matrix A, for example, okay, and if you diagonalize this, you will get this form where A is equal to P, D, P inverse. D is the diagonal matrix of the eigenvalues and P is the eigenvectors matrix, and if all the eigenvectors are linearly independent, this matrix A is diagonalizable and P inverse exists, you can write this form. So here this A is replaced with Q, that's all. Okay, so obviously if you multiply both sides with P inverse into Q is equal to P inverse PD P inverse. Okay, so obviously matrix multiplication is associative, so P inverse into P, this gives you identity matrix. So P inverse QP is equal to D P inverse into P. If you post multiply here, here also you should post multiply, so this gives you again an identity matrix. So therefore this P inverse QP is just the diagonal matrix of the eigenvalues, that's all. Okay, is this okay to all of you? The P inverse DP value is the actual Q matrix, okay, or this diagonal matrix D is P inverse QP, whatever, either this or this, both are same because of this simple manipulations. Okay, so now let's see here. So clearly this matrix is a diagonal matrix. Now what they're asking you, the sum of absolute values of all the elements of P inverse QP. So P inverse QP is a diagonal matrix. So let's say you have lambda 1 0 0 0, lambda 2 0 0, lambda 3 actually here. So this is what you should understand by looking at this question. Okay, it's diagonalizable. So this matrix is going to be diagonal matrix. So the sum of all the elements of this matrix is nothing but sum of all these elements, but they were asking you the absolute sum. Okay, so therefore absolute sum of elements is equal to, so anyhow 6 elements are zeros, so you have mod lambda 1 plus mod lambda 2 plus mod lambda 3. That's all. Okay, so sum of absolute eigenvalues. No, it's not trace of Q. Okay, sum of eigenvalues is trace of Q, but some eigenvalues can be negative. Got it? Did you understand? Sum of eigenvalues is trace. So people looking at this, they are happy to calculate the trace and add. But if eigenvalue is negative, okay, then this answer would be different. Clear? That's the reason. In fact, if this is a MCQ, first option is 6. Okay, I know, because there are legends and they'll just count 3 plus 3 and enter 6. That's the reason why 6 is given as the first option. But mod lambda 1 summation or mod lambda summations and direct lambda summations is not same, need not be same. Okay, so chalo, let's calculate the eigenvalues of this matrix then. See, whatever I have taught till now is concept. Okay, this should be known to you generally. Like this is a matrix, this is a 3 by 3 matrix, then if this is the case, it's a diagonal matrix. Knowing all these points will make you understand to write this step as the first step of your problem. Okay, so let's calculate the eigenvalues of the given matrix. So what is Q? 3 2 4 2 0 2 4 2 3. Correct, no? 3 2 4 2 0 2 4 2 3 actually. So we'll construct the characteristic equation. We'll get a cubic equation. So this implies characteristic polynomial is lambda cube minus trace 6 lambda square plus sum of the minus 4 plus 9 minus 16. 9 minus 16 is how much? Minus 7 plus minus 4. Correct, no? So if you see this element, if cross this minus 4 plus, if you round off this element and delete this, 9 minus 16 minus 7 plus, if you delete this, then minus 4. So minus 8 minus 7 minus 15 minus 15 lambda plus the determinant. So what's the determinant value? 3 into minus 4 minus 2 into 6 minus 8 minus 2 plus 4 into 4. So this is minus 12 plus 4 minus 12 plus 4 is minus 8. Correct, no? Minus 12 plus 4 is minus 8. Minus 8 plus 16 is 12. So plus 12 is equal to 0. So this is the equation that you have. Okay, so this would be the characteristic polynomial for this particular matrix actually. Okay, so it's a cubic equation. Any idea to solve this? Any idea to solve this cubic equation without properly going through trial and error? So lambda cube minus 6 lambda square plus elements are correct, no? 3 2 4 0 2 2 3. It's a symmetric matrix, right? So it has all real eigenvalues definitely. So sum of absolute values, absolute eigenvalues. Actually there is a technique if you would like to do, but synthetic division is okay, but to do synthetic division you should know one root. So 12 minus 6 is 6, 1 minus 15 is minus 4. So lambda cube minus 6 lambda square minus, so if you simplify this, then correct, no? Determinant is this, sum of the principal minus is minus 15 minus 4 plus 9 minus 16 minus 7 plus minus 4. So this is minus 15, correct. So minus 15 lambda, determinant is 12 plus 12, na? 3 into minus 4 minus 2 into 6 minus 8 minus 2 plus 4 into 4. So 16 plus 4, 20, 20 minus 12, 8. So this should be 8, no? It's not 12, it's 8 is equal to 0. Is it correct, no? Determinant value 3 times minus 4 minus 2 times 6 minus 8 minus 2 plus 4 times of 4. So 16 plus 4, 20, 20 minus 12, 8. So you have 8 as the eigenvalues. So sum of coefficients is 8, 9 minus 6 minus 15, no, wrong. 1 minus 15, no, minus 1 and plus 1 are not the roots of this equation. So, but I think actually there is a technique to solve this matrix. Okay, there is something called singular values concept which is deleted because this question is before 21, yeah, 2019. So that's the reason why this question is given actually. Okay, so because if you see there is some concept called singular values. Okay, it's a symmetric matrix. So if you calculate eigenvalues of A transpose A, okay, you'll get lambda squares and the quadratic the equation would change actually, and positive values of that singular values are the absolute eigenvalues actually. Like if you see A transpose A, if you consider, and if you calculate the eigenvalues of this matrix, then you will get lambda 1 square, lambda 2 square, lambda 3 square when A transpose is equal to A, which means it's a symmetric matrix. Okay, but if you multiply A transpose A, then definitely your characteristic equation will change. So you should solve this equation. So let's do it this way maybe. So A transpose A, but I think calculation wise it's hectic. So what about 3? Let's see, because coefficients looks like 6, 15 are the leading towards the diagonal. So if you put a 3, 27 minus 6 times of 9, 54 minus 45 plus 8. What is this value? 27 plus 8. No, this is non-zero clearly. Okay, so let's solve this equation using a solver maybe for now. So cubic solver. So we'll put a cubic solver to solve this. X cube plus bx square. So this is 1, this is minus 6, this is minus 15, and this would be how much? Last it is 8, correct? No, it should be 8 plus 8 is equal to 0. So calculate, we'll get the roots. So 2.24943. so lambda 1 on solving, lambda 1 is equal to minus 2.24943. Lambda 2 is 0.45636 and lambda 3 is equal to 7.79306. So summation of absolute lambda I is equal to, if you change the all signs to positive and if you add, so it's 11 not 15. Where? This one. Are you sure? Matrix is correct, no? 3 2 4 3 2 4 2 0 2 4 2 3 4 2 3. Okay, so then principal minor of 3 is 0 minus 4 plus principal minor of this value is 9 minus 16 minus 7 plus 0 minus 4. So this is minus 4. So minus 8 minus 7 minus 15 only, no? It should be minus 15. Yeah. Shall we check whether we are doing mistake? Let us do the eigenvalues calculator so that we can do it better. We can check it fast. Eigenvalue calculator. Okay. So we'll feed it in Wolfram alpha, of course, it's easy. Or else let's do it in this way. Okay. So let's enter the elements. What are the elements? 3 2 4 2 0 2 3 2 4 2 0 2 then 4 2 3. Okay, so that's what you matrix you want. So we want eigenvalues, right? So let's calculate. Yeah, so if you calculate eigenvalues, minus 1 8. Oh, is it? Then we made some mistake in the equation. 6 lambda square. This should be minus 8, no? Correct, this should be minus 8, no? Minus 8, is it? Let's solve carefully this characteristic polynomial. Characteristic polynomial for this symmetric matrix. Okay, let's calculate directly. Okay, maybe plus 6. No, I think there is some catch in the characteristic equation. Let's calculate carefully. 3 minus lambda 2 4, 2 minus lambda 2 4, 2 3 minus lambda, okay, is equal to 0. So let's do this. 3 minus lambda times minus lambda into 3 minus lambda, so lambda into lambda minus 3 minus 4 minus 2 into 6 minus 2 lambda minus 8. Okay, so 6 minus 2 lambda minus 8 plus 4 into 4 plus 4 lambda is equal to 0. Fine. So this is lambda square minus 3 lambda minus 4. So lambda square minus 3 lambda minus 4. This is 6 minus 8 minus 2. So let's see the calculation once again. 6 minus 8 is minus 2. So minus 2 minus 2 lambda. So 2 plus 2 lambda. And here plus 4 plus 4 lambda. Okay. So then if you simplify, you would get, you multiply minus here. So to make this lambda minus 3, then you make a minus here. It should be minus 2. Then this should be minus 4. So if you simplify this, lambda cube, then lambda square terms, minus 3 lambda square minus 3 lambda square minus 6 lambda square, correct? Then lambda terms, lambda into minus 4 minus 3. So this is plus 9 lambda minus 4 lambda, 5 lambda, 5 minus 4 lambda, 1 lambda, 1 minus 16 minus 15 lambda. Then determinant. So what would be the determinant actually? 3 into 4, 12, 3 4s are 12, 12 minus 4, 8, 8 minus 16 minus 8 is equal to 0. Okay. So then if you see, 1 minus 15 is minus 14, minus 6 minus 8 is also minus 14. Yeah, that is 8, no? Correct. That's the mistake we made. That should be minus 8. So then here in this case, you can see clearly, if this is 1, sum of coefficients of odd powers is same as sum of coefficients of even powers. So lambda is equal to minus 1 is root. Lambda equal to minus 1 is root actually in this case. So if lambda equal to minus 1, then you know the other two eigenvalues, lambda 1 plus lambda 2 plus lambda 3 is equal to 6. Okay, one eigenvalue is minus 1, you know this. So lambda 2 plus lambda 3 should be 7. Okay, then lambda 2 into lambda 3 is equal to minus 8. So the thing which satisfies these two is 8 comma minus 1. So minus 1 minus 1 8. These are the eigenvalues in this case. Okay, sorry, the determinant I have done wrong, so that's the reason why it has come up. Normally you need not do this full thing to get the characteristic equation. Okay, the technique, if you know, if you have this matrix, okay, 3 2 4, for example, any matrix 4 2 3, then the characteristic equation is lambda cube minus trace of A. So what is this trace? 6. So 6 lambda square plus sum of principal minus. So what are principal minus? Let's see. If you take this element, then delete this column and this row, calculate this determinant of 2 by 2. Okay, so what is this determinant of 2 by 2? 0 minus 4. So the first element is minus 4 plus again calculate the principal minus of this diagonal. So you delete this column and this row. So 3 3s are 9 minus 16, which is minus 7 plus coming to this element again. So you delete this column and this row. So 0 minus 4. So this is minus 4 times lambda. So minus plus again minus determinant of A is equal to 0. So in this case, if you calculate the determinant of A carefully, 3 times minus 4 minus 2 into minus 2 into 6 minus 8 minus 2 plus 4 into 4. So 16 plus 4 20, 20 minus 12 is 8. So this value is 8. That's how you can form the characteristic equation in a single line. Okay, in fact you need not do this full stuff, like you need not do this and do the simplification, minus signs and all. You can calculate the characteristic equation in this form. Okay, so this equation would give you lambda cube minus 6 lambda square minus 15 lambda minus 8 is equal to 0. So for which minus 1 8 are the roots. Therefore summation of mod lambda I okay, is equal to mod of -1 plus mod of -1 plus mod 8, which is 10 actually in this case. Okay, did you understand? It took some time because we have done the miscalculation of the determinant of the matrix. That's the reason. Otherwise it should be on the level. Okay, so you should be very careful in calculating determinants, especially this minus and all. Generally, whenever, if at least for 3x3 matrix, if I want to form characteristic equation, I use this technique. Okay, rather than simplifying this determinant, we can go with this technique so that you'll get the answer in one line. Okay, is this clear? Okay, did you all understand how to write characteristic equation in a single line for at least for 3x3 matrix? 2x2 anyhow you know. So if I give you a 3x3 matrix, did you all understand how you can write a characteristic equation in a single go in one line? Yeah, fine. Okay, so let's move to the next question. MCQ 2019 2 marks question. Okay, solution. If p of x is equal to ax cube plus bx square plus cx plus d is the polynomial obtained by the Lagrangian interpolation. Okay, so we have obtained some polynomial based on the interpolation. So what is an interpolation? Let's say if you perform an any experiment, okay, and you are fixing some x coordinate and you are getting y values in that experiment. So definitely, let's say you got your data points like this, for example. Okay, one way to get a nice understanding of the data is regression. Okay, normally you do the linear regression, least square regression, all these things, but the general powerful technique is interpolation. Okay, you will see always interpolation results would be better than regression results, because in case of regression you will just get a line like this. Let's say if you're doing least square regression with single line with first order, so you will get a line like this. You won't capture the trend of the points, but in case of interpolation you will get a curve something like this connecting all the data points. Okay, and you'll get the equation of the curve. So this curve consists of all the data points which are actually available. Okay, so that's why even if you see the solvers and all, they work on the interpolation techniques than the regression techniques. Okay, so chalo, let's see. This is some polynomial which you obtained, ax cube plus bx square plus cx plus d. It's a cubic polynomial you obtained by the regression, and it's given, it's cubic, so definitely there should be 4 points. So you see p of 0 is -8, p of 0 is -8, so this implies d is equal to -8, correct? Because if you put x is equal to 0 in this case, you will be left with only d, so p of 0 is equal to d and d should be -8. That's equation 1, of course. Then let's see, p of 1 is equal to -7. So what does this give you? A plus b plus c plus d is equal to -7, and this d is equal to -8. So this d is -8. So if you shift here, you will get a plus b plus c is equal to 1. Okay, so this is one relation between a, b and c, of course. Next, let's see, p of 2 is equal to -6. So this implies if you put x is equal to 2, you have 8a plus 4b plus 2c plus d, which is -8, is equal to -6, of course. Okay, so if you shift this 8 to the other side, you'll have this equation as 2. So then we get 4a plus 2b plus c is equal to 1. That's one equation. Okay, so finally you will have one more point. So what is the one more point? Actually, this is the point, p of 4 is equal to 20. Let us even simplify that. So p of 4 is equal to 20. Okay, so p of 4 is equal to 20. So if you put 4 here, you'll have 64a plus 16b plus 4c minus 8. Also this can be written as 28 actually here. So if you divide with 4, 7. So this gives you 16a plus 4b plus c is equal to 7 actually. So this is third equation. Okay, so you have three equations with three unknowns. Now you can solve, you can get the values of a, b, c, and you can calculate what is a minus b plus c actually here. Okay, is this clear? So since if you generate any interpolated curve, then all the data whatever is physically present should lie on this curve. So this curve should satisfy all these points. So that's why we have substituted. So you have now three equations with three unknowns. You should be able to solve. Okay, is this fine? So let's call these equations to be. So how do you solve this? 1 okay, I think we have already given 1, 2, 3, 4. Okay, so let's for example do 3 minus 2. So what does 3 minus 2 give you? 4a minus a, 3a plus 2b minus b. B, cc gets cancelled, so this is 0. So b is equal to minus 3a in this case. Similarly, if you do for example 4 minus 2, there are plenty of techniques to solve this 3 by 3 system. You know, you have learnt so many techniques like matrix forms and all, but anyway it's simple algebra. So let's simplify this. Okay, so then like for example if you do 4 minus 2, in this case 16 minus a, 15a plus 4 minus b, so you have 3b, then c minus c gets cancelled, is equal to 7 minus 1 is 6. Okay, then 5a plus b is equal to 2. So 5a plus b is equal to 2 actually, but you know b is equal to minus 3a. So if you put b equal to minus 3a, you will get a is equal to 1, then b is equal to minus 3. So if you put both of them here, a plus b plus c is equal to 1. So minus 2 plus c is equal to 1. So c should be 3 actually. Okay, now a minus b plus c. So 1 plus 3 plus 3 is 7 is the actual answer. Okay, interpolation questions are very common. Okay, so especially in XC exam. So whatever they give you, whatever the points they give you, those points should satisfy the polynomial. Please keep this in mind. Okay, because the main criteria behind interpolation is the interpolated curve should pass through all the data points given. Okay, yes, is this clear to all of you? Come on guys, type it in the chat box. Is this okay or no? Which of the numerical methods most frequently asked? Newton-Raphson, then interpolation, then RK fourth order. Sorry, not RK fourth order, Euler. Okay, so Euler's method, people ask these things. Done. So let's see. So 7 is the correct answer, of course, because a minus b plus c is 7. Okay, again 2 marks, luckily, very easy stuff. So let's see again some form that we have solved like yesterday. 2018 XC 1 mark. For real numbers alpha 1 and alpha 2, if the formula minus 1 integral minus 1 to 1 f of x dx is alpha 1 f of minus half plus alpha 2 f of half is exact for all polynomials of degree less than or equal to 1, then 2 alpha 1 plus alpha 2 equals. Okay, so basically it's like some trapezoidal rule. Okay, so let's see. Since it's valid for all polynomials of degree less than or equal to 1, let f of x is equal to a naught x plus a1. So this implies integral minus 1 to 1 a naught x plus a1 dx is equal to alpha 1 times f of minus half. So if you put x is equal to minus half, you have minus a naught by 2 plus a1 plus alpha 2 into f of half. So a naught by 2 plus a1. So let's compare both sides. Okay, so if you compare both sides, this is odd function because a naught is constant and integration of x is an odd function. So first part would contribute to 0 definitely. So this integration is 2 times of a1 is equal to a naught. If you take a naught, then you have minus alpha 1 by 2 plus alpha 2 by 2 plus a1 into alpha 1 plus alpha 2. So this is what you get. Okay, and now if you compare both sides, then definitely this term here should be 0. Why? There is no a0 term on the left hand side. Okay, and a1 coefficient, which is this term, should be 2 actually. Okay, because there is 2 here. So this tells you alpha 1 plus alpha 2 is equal to 2, and since this has to be 0, alpha 2 minus alpha 1 has to be 0. So these things are same. Okay, so alpha 2 is equal to alpha 1, which is equal to 1. So 2 times of alpha 1 plus alpha 2 is 3. Okay, come on, is this clear to all of you? This is normally called the midpoint rule. Okay, is this clear to all? It's a very straightforward question for 1 mark, simple question. So they have given some quadrature method which fits for all polynomials less than or equal to 1. So this is the generalized technique to solve this. Okay, then let's see. It's a simple question, 2018, 1 mark question again. Solution: if f of x is continuously differentiable real valued function, so it's continuously differentiable. The first step, so how to let fx this function, because this is valid for all polynomials of degree less than or equal to 1, correct? So what is the general form of a polynomial? F of x is equal to a0 plus a1x plus a2x square and so on. Okay, that's the polynomial. So if you want linear polynomial, this is the part. Okay, so that's how I have taken that function. Okay, Vibhu, Prabhat, Dhaval, Navneet, Surya, Mahavir, Akash, every one of you. Okay, so let's solve this. Fine. So let's solve this question. Then f of x is equal to bx plus a if x is less than 1, and 5x square if x is greater than or equal to 1 actually. So first of all, it's continuously differentiable, means the derivative keeps existing. Okay, like if you take function of e power x, its derivative keeps existing. You take differentiation, integration here, the differentiation, the derivatives exist at all the places. That's what they mean. Okay, so first of all, for continuity, so this implies x tends to 1 if the function is continuous. Okay, then definitely, and if you are trying to calculate the limit x tends to 1 is x is not equal to 1. Okay, so if x is not equal to 1, if you take this bx plus a, this should be equal to f of 1. So when x is exactly 1, this is 5x square, so 5. So a plus b should be 5. This is one set of equation. Okay, it's also given this function is continuously differentiable. Okay, so if it is differentiable, if you calculate f dash of x, this gives you b if x less than 1, 10x if x is greater than or equal to 1. Okay, so these are the derivative values of this function. Now if derivative has to exist, then again, you know, limit x tends to 1, f dash of x should be equal to f dash of 1. So this gives you, when x is not equal to 1 or less than 1, whatever, this value b is the direct limit here. F dash of 1, when you put x equal to 1, this value is 10. So b value is 10. So a value is, b is 10, so a is minus 5. Okay, so you need a square b. So therefore a square b is minus 5 whole square into 10, which is 250. Okay, so that is the correct answer. Okay, 250 is the actual answer in this case. First it should be continuous, so this should match. Similarly, it should be differentiable. So you calculate the derivative and equate the derivative from the left hand side and the right hand side. So then you will get b is equal to 10. Okay, a very straight simple question, again from simple concepts of calculus, fundamental calculus. 2018 𝐂𝐸 2 marks. Okay, so let's see. Given a is equal to 5 minus 3 6 minus 4. Okay, so trace of a power 1000. So what is this value? Okay, so trace of a power 1000. So first of all, if you look at some basic formulas of or basic characteristics of eigenvalues, if this matrix has lambda 1 lambda 2 eigenvalues, this implies lambda 1 power 1000 and lambda 2 power 1000 are eigenvalues of a power 1000. Correct? This is what you know. This is the matrix A. Okay, A is 5 minus 3 6 minus 4. Okay, so if you raise A power 1000 times, okay, then what should be the trace of that matrix? See, it's a 2 by 2, so you calculate a square, a cube, a power 4, you keep doing it till you reach a power 1000. Okay, then again your matrix is 2 by 2 matrix. Okay, it has two eigenvalues, and that two eigenvalues would be lambda 1 power 1000 and lambda 2 power 1000 actually. Okay, so let's see what are the eigenvalues of this matrix. So since lambda 1 plus lambda 2 should be equal to trace of A, and what is trace of A? 5 minus 4 1, so this value is 1, and lambda 1 lambda 2 is equal to det A minus 20, correct now? So 5 4 is the minus, sorry, 5 4 is the 20 minus of this, so plus 18, so minus 20 plus 18 is minus 2. So these two implies the eigenvalues are nothing but 2 comma minus 1, so that if you add them you will get 1, if you multiply them you will get minus 2. So if these are the eigenvalues of this matrix, then the eigenvalues of this matrix are nothing but these values. So therefore eigenvalues of a power 1000 are 1 power 1000 or 2 power 1000 comma minus 1 whole power 1000, which is equal to 2 power 1000 comma 1. So these are the eigenvalues of a power 1000. Okay, so for any matrix the sum of the eigenvalues is its trace. So if you want trace of this a power 1000, you should add those two. So to the 2 power 1000 plus 1 should be the eigenvalue, should be the trace of the matrix actually. Okay, so B is the correct answer. Is this fine to all of you? Yes or no? See, in exam you can't calculate, you keep on calculating a power 1000. Okay, it's like never ending task. Fine. Then let's solve this question. A line integral from 2 marks, again 2018 𝐂𝐸. Let R cube denote the 3D Euclidean space, and F is this vector minus y I cap x j cap plus z k cap for all x y z. If C is the curve described by the parametric equation R of t is equal to cos t I cap plus sin t j cap plus 2t square k cap, then the value of the line integral cyclic not cyclic integral over C f dot d r bar. Okay, so it's a line integral basically. So let's see. Solution: denote the 3D Euclidean space, and f is equal to, maybe these are bolded, they did not keep it. So given plus z k cap, and all x comma y comma z belongs to this real numbers. C is the curve described by the parametric equation. So this C is such that the parametric equation is cos t I cap plus sin t j cap plus 2t square k cap. Okay, so plus 2t square k cap. Then let's see, if you want to calculate this integral, and it's a parameterization, so t goes from 0 to 1. Okay, so t goes from 0 to 1 actually, which is even given here because it's a parametric curve obviously. Okay, so then integral over c f dot dr is equal to integral over c first f, which is minus y I cap plus xj cap plus zk cap. Okay, dot dr. So this is the radius, this is the position coordinate vector. So if you differentiate this with respect to if you differentiate this, okay, so dr is equal to derivative of cos minus sine t I cap plus derivative of sine cos t j cap plus derivative of 2t square 4t dt actually. Okay, so this is what you have, and you are performing this integration along this path c. So along this path c, your t is going from 0 to 1, then minus y. So along this path y value is given by sin t, so this is minus sin t I cap plus along this curve x value is cos t, so cos t j cap plus 2t square k cap into minus sin t I cap plus cos t j cap plus 4t dt. That's the integration. So you can see it's a 3D line integral normally, but you have converted that 3D line integral using parameterization into a single variable integration now. Okay, because the dot product of these two would give you some function in terms of t, and t goes from 0 to 1, so you can perform this integration. So therefore f bar dot dr bar is t goes from 0 to 1 minus sin t into minus sin t, so sin square t plus cos square t, so which is 1 plus 4t into 2t square, so 8t cube. So this integration is, that's all. Okay, so its answer should be 3 actually. Okay, right now this integration value, if you check, integration of 1 is t, so 1 minus 0 is 1 plus 8 into t power 4 by 4, so 2 into 1, yeah, it should be 3. Fine. It's okay. So in this, is this parametric form of cylinder? Generally yes, because if you see x square plus y square equal to 1 and z keeps changing with time. Okay, so it's a cylinder basically from 0 to 1. Normally used to model the filling of flow inside a cylinder. Okay, for height of the fluid columns. So if you see, yeah, I can repeat. So given this is the function f, and you want the integration about this path c, where c is given by this. Okay, in the parameterization form you can see this is x, this is y, and this is z, because this r bar position vector is given as xi plus yj plus zk. So the parameters are defined as x equal to cos theta, cos t, y equal to sin t, and z is equal to 2t square. So if you do f dot dr, if you differentiate both sides, okay, d r of t is equal to minus sin t dt I cap plus cos t dt j cap plus 4t dt k cap. Okay, so that's why minus sin t I plus cos t j plus 4t times dt. So this complete vector is dr bar. Okay, and you have f, so you write f, but when you are integrating along this curve, see, this x can be replaced with sin cos t, y can be replaced with sin t, and z can be replaced with 2t square. So when you do the dot product of f dot dr bar, so f dot d r bar actually, which is in terms of t. Now this is a full integration in terms of only t, so it's a single variable you can do. Okay, you can see minus sin t into minus sin t, sin square t plus cos square t, which is 1 plus 8t cube, so 1 plus 8t cube dt. You cannot use Stokes theorem because this c is not a closed path. Okay, Stokes theorem you can apply only if the path is closed, but here this path is not closed. Okay, fine, Shama. Normally Stokes theorem tells you this. if you have a cyclic integral f dot dr bar, so this is integral over the region enclosed by the C, curl f dot n cap ds, or you can say yes. This is what you have the curl or the Stokes theorem basically, okay. And that's why in case of basically conservative fields, this term on the right hand side curl f is 0. That's why this cyclic integral of f bar dot dr bar is 0 if f bar is irrotational field, okay. But to perform this, you should know this, you should have the criteria that the path is closed, which is not in this case, okay. So 3 should be the answer. Anyway, it's a single variable integration, you perform it. 2017 XE 1 mark. So let's see solution. For alpha greater than or equal to 1. So what is the value of alpha? Okay. Can you provide notes for quick revision? My notes, which I teach in the class, but it's a very big notes, you know, I don't even have it merged. Yeah, I had only the topic wise notes, in fact, like lecture wise notes, in fact, okay. That too I have to download from the app somewhere, but I don't have a full like merged notes actually. It's okay, if you have doubts at any point, please ask me, okay, I'll clarify it. So then let's solve this question. So I is equal to integral 0 to pi. So first of all, clearly these are functions of y, okay. So if these are functions of, sorry, these are x functions, so these are y limits and this is x limits, okay. So x is equal to pi by alpha. Now clearly integrating sin y by y with respect to dy is not very happy thing to do, okay. Like integration of sin y by y with respect to y is not a very happy deal to do with, okay. So if this integration in this sequence is not very happy thing to do, then what will we go for? Any suggestion? Any suggestion that something can be done, maybe to, you know, make it easy? Change of order, correct? So change of order of integration. So by change of order of integration, okay. So if you have this, then first let us plot the points. What all you have? Sorry, the curves. X equal to 0, x equal to pi by alpha, y is equal to x, y equal to pi by alpha, okay. So if you plot, alpha is a constant and alpha is positive, definitely, you know, because alpha is greater than or equal to 1. So x axis, y axis, okay. So x is equal to 0, y is equal to x. Then if alpha is more than 1, okay, so let's say if alpha is for example 2 or 3, 4, whatever, then you'll have a line. So you'll see that this is y is equal to pi by alpha and this is x is equal to pi by alpha. X is equal to pi by alpha and y is equal to pi by alpha, okay. And this is the point, obviously, pi by alpha comma pi by alpha, okay. Now here you see there are two regions. One is, let's say, this one, and second region is this one. Out of these regions 1 and 2, which is the region we should consider? Anyone? Out of the regions 1 and 2, which region should I consider for evaluation? One, is it? Yeah, because in last class I have told you some point. If you take a region, all the boundaries of that region, like for example if you take one, this line, this blue and this diagonal, should lie in this case, okay. But if you take equation 2, this boundary x-axis, which is y is equal to 0, you cannot find here, okay. So this xy axis you have just drawn for the reference, but the equation y is equal to 0, which is x-axis, is not mentioned anywhere in this, okay. So therefore this doesn't act as a boundary of this problem, and you will be looking at only this first region, okay, y equal to x. Then if you change the order of integration, I is equal to integral sin y by y dx dy, because the first variable of integration is y, so if you change, the first becomes x, so you should write x limits, okay. So if you want x limits, like in the last class I have told you, you consider a horizontal tip in this case. Now in this region, wherever you move this up and down, left hand side is always bounded by x equal to 0, right hand side is always bounded by x is equal to y, correct. So this is always bounded by x equal to 0, and this is bounded by x equal to y. Now coming to y values, y is least at 0 and y is maximum at pi by alpha, okay. So y is equal to 0 and y is equal to pi by alpha actually. So that's how, using that graph, this integral which is given like this now will shift like this, okay. Now you can perform the integration easily. I is equal to y equal to 0 to pi by alpha, x is equal to 0 to x is equal to y, sin y by y dx dy, okay. Now if you integrate with respect to x first, okay, because you are integrating with respect to x, and this complete function is a constant, okay. So if this full function is a constant, then sin y by y is a constant into integral dx with respect to this is nothing but y into dx, sorry, dy actually, okay. So this is what you would get, yes or no, because sin y by y behaves as constant. So integral 0 to y dx is nothing but integration of dx is x, and if you substitute the limits you will get y. So then this y and this y gets cancelled. Now it's a simple stuff. So this integration value is given as 1 by 2, okay. So 1 by 2 is equal to 0 to pi by alpha sin y dy. So 1 by 2 is equal to integration of sin minus cos 0 to pi by alpha, so half is equal to 1 minus cos pi by alpha actually, okay. So 1 by 2 is equal to half is equal to 1 minus cos pi by alpha, so cos pi by alpha is equal to half, so alpha should be 3 actually, okay. So where can we get the previous year book for XC maths? To be frank, there is no book in the anywhere it's available. To be frank, you know, I plan to release a book some time back, like some 2.5 years back, but later got busy in other commitments, okay. There's no previous year book for XC maths, frankly speaking. Okay, so alpha is 3 in this case, okay. That's all. You change the order of integration and do this, it is 3. But the story is it's a 1 mark question. So let's solve this. Solution looks like a simple question after some hectic things. 3 fair dice are rolled simultaneously. The probability of getting a sum of 5 is dash. Come on, tell me. The probability of getting a sum of 5. 3 dice are rolled actually, okay. So first of all, if you roll 3 dice, the total number of ways is 216, okay. So total number of ways or as you can see 6 into first die can fall in 6 ways, second die can fall in 6 ways, third die can fall in 6 ways, out of which there is some limited cases where the sum is exactly 5. So for the sum to be exactly 5, let us see the possibilities. Okay, the ordered pair can consist of 1 1 3 for example. Okay, like you can see the first die falls 1, second die falls 1, and the third die falls 3, let's say. Okay, or 1 2 2. Okay, 1 2 2. Of course, can you form any other combinations? No, right? Because if all 3 dice form 2, it would be 6. If all 3 dice form 1, then it would be 1. Sum is equal to 3 actually. Okay, so for the sum to be 5, only these are the possibilities. Now, which means this 3 can be here or here at any place. So probability is equal to this 3 can be like first die can fall 3, second die can fall 3, or third die can also fall 3 actually. Okay, so 3C1 into the probability of getting this is 1 by 216, plus similarly here also this 1 can be here or here anywhere. So 3C1 into 1 by 216. So 6 upon 216, which is 3 divided by 108. That's all. Okay, so 1 by 54. So 1 by not 54, no. So 1 by 36. So 1 by 36 should be the answer. Yeah, D should be the correct answer in this case. Did you all understand why did I write 3C1? Because this 3 can be happening at any one of these 3 places. It can be 311, 131, or 113. Okay, so 3 cases. Similarly here, this 1 can go anywhere. It's 122 or 212 or 221. Okay, so totally have 6 chances. So 6 out of the 216 cases would give you the answer actually. Okay, so 1 by 36 is the perfect answer for this case. Okay, it's a 1 mark question, that's why simple question. Chalo, interpolation question. Let's solve this. Suppose alpha, beta, gamma and delta are constants such that p of x, the polynomial, is delta plus gamma of x plus 1, beta x of x plus 1, alpha x of x plus 1 into gamma x minus 1. So this is normally the interpolating polynomial, Lagrange's polynomial. It is the interpolating polynomial for the data minus 1 comma minus 3, 0 comma 1, 1 comma minus 1, 2 comma minus 3. Then the value of gamma minus beta is dash actually. Okay, so let's see. Given p of x is equal to delta plus gamma of x plus 1 plus beta x of x plus 1 plus alpha x of x plus 1 into x minus 1. Okay, so this is the polynomial which you have generated. Now you want to figure out what are the values of the coefficients. Okay, so you want gamma minus beta. Okay, so let's see. Points are minus 1 comma minus 3, 0 comma 1, 1 comma minus 1, 2 comma minus 3. Okay, so if you are doing the interpolation, as I have told you, these 4 points should lie on this polynomial. Okay, so all these 4 points should lie on this polynomial. So if you substitute first, if you substitute the first point, p of minus 1 should be minus 3. So minus 3 is equal to delta plus, when you put x equal to minus 1, this term is 0, this term is 0, and this term is also 0 actually. So delta is equal to minus 3. That's all, the first equation. Then the second, if you put this value, p of 0 is equal to 1. So if you put p of 0 here, x is equal to 0. So p of 0 1 is equal to delta plus gamma of, if you put x equal to 1, this is 2. Sorry, if you put x equal to 0, this is 1 actually. Then if you put x equal to 0, this term is 0 and this term is also 0. So this gives you, if you put delta is equal to minus 3, then gamma is equal to 4. Okay, so this is gamma is equal to 4. Similarly, let's go with this point 1 comma minus 1. So if you replace here, p of 1 is minus 1. So minus 1 is equal to delta plus, if you put x equal to 1, 1 plus 1, 2 times of gamma, plus if you put x equal to 1, 1 into 2, so 2 times of beta, and if you put x equal to 1, this term is 0, the last term. So let's see, minus 1 is equal to delta plus 2 gamma, which is 8 plus 2 beta. Okay, so what would be 2 beta value then in this case? 3 minus 1 2, 2 minus 8 minus 6, so beta is minus 3. Beta is minus 3. Okay, so you can see gamma is 4, beta is minus 3. So now you want gamma minus beta. That's all. Okay, so 7 is the answer. You see, in interpolation, very simple questions turn up. In fact, the same kind of question has also come in GATE 2023. Okay, so that's why in XE PYQs I'm solving only those questions which come up very frequently, at least. Okay, so that you would get better idea. Okay, let me have some water meanwhile. If you have any doubts, you can ask me in between. Okay, so feel free to ask some doubts if you have any. So if you have any questions about maths, fluids, thermo, okay, or else XE exam, okay, or any general thing, you can ask. I'll be for 2-3 minutes. So interpolation numerical techniques is different. No, this is numerical techniques. Okay, this itself is the interpolation. Fine. दमो क्लियर है. सॉम्बी मैथ्स में बस थोड़ा प्रॉब्लम है, क्या करना चाहिए? तो डोंट वरी, लाइक दमो क्लियर है. सॉम्बी मैथ्स में, अच्छा सॉम्बी मैथ्स में बस थोड़ा प्रॉब्लम है. सो डोंट वरी फॉर मैथ्स, जस्ट कीप मूविंग विद द PYQ सेशंस. ओके, there is no Laplace and Fourier transform. Yes, there is Fourier series but no Fourier transform at least. I have not prepared applied demo. Please prepare, because applied demo you'll find a lot of easy questions in XE, but at the same time from air conditioning or Rankine cycle you'll find slight tricky questions, but rest are like auto, diesel, dual cycle is not there. So how to increase speed, sir? I started with you, but I'm 10 minutes slow in this session. See, it's okay, just keep practicing. Okay, that gives you speed, but it's okay. Accuracy is more important than speed in GATE. Okay, so whatever you do, even if you do it 1 minute or 2 minutes late, please solve it correctly. Okay, so how can I prepare in less time? Just follow these sessions. Okay, at this point it would be the best. Okay, Adarsh, chalo. So this is 7 anyway. So let's solve this. Consider the system of linear equations. 2x2 plus x3 is equal to 0, minus 2x1 minus x3 is equal to 0, minus x1 plus x2 is equal to 1. The above system has unique solution, infinite number of solutions, no solutions, only 2 distinct solutions. Okay, so given system is x2 plus x3 is equal to 0, okay, and minus 2x1 minus x3 is equal to 0, minus x1 plus x2 is equal to 1 actually. Okay, so minus x1 plus x2 is equal to 1. So if you write this as a system of equations, you would end up with 0, 2, 1, minus 2, 0, minus 1, minus 1, 1, 0, x1, x2, x3, 0, 0, 1, of course. Okay, so this is the matrix. Clearly it's non-homogeneous system because you have 1, this is not a completely 0 vector. So how do you decide the consistency? It's simple questions, like these questions even come in mechanical many times. So if you form the augmented matrix, so let's call this system, say AX is equal to some system B, okay. So then augmented matrix, A augmented with B. So if you see 0 2 1 0, okay. So minus 1 1 0 and 0 0 1. So now if you try to make these elements 0, okay, so clearly you cannot make these two 0, so you cannot convert to Euclidean form. So what we'll do, we'll swap this, okay, because see, you cannot do column swappings, but you can do row swapping. Why? If you do row swapping, it's just like swapping these equations, okay, but if you do column swap, then what happens, or if you change any columns, then the coefficients keep changing and then the system gets changed, okay. So you should not change the system, you should solve the same system, but slightly you can change the order. So if I swap to R1 and R2, this becomes 0, oh sorry, minus 2 0 minus 1 0 0 2 1 0 minus 1 1 0 1 actually, okay. So this is what you would get. So then you apply the transformations, then you see minus 2 minus of minus 2, so this is plus 2 0, then 2 times of R3 minus this, so 2 times of R3 minus 1, so this is plus 1, and obviously 2 times of this minus 0, so we have 2 actually here. Then if you apply the transformation, R3 changes to R3 minus R2, minus 2 0 minus 1 0 0 2 1 0 0 0 0 2 is what you have. Now if you see this equation, last equation tells you, first of all, rank of A is not equal to rank of A augmented B, but anyway this equation tells you 0 into x1 plus 0 into x2 plus 0 into x3 is equal to 2. Is this possible? Anyone? The last equation tells you 0 into x1 plus 0 into x2 plus 0 into x3 is equal to 2. So can you get this in any sense? Whatever might be the values of x1, x2, x3? No, correct? So therefore no solution. Okay, so that's how you have no solutions. Okay, yeah. So then let's go to the next question. Anyway, this is a simple question. Now let's solve this again. Euler-Cauchy 2017. So but this time it's a non-homogeneous equation. Okay, so let's solve this because some of you have asked how to calculate the particular integral in this case. Okay, so we'll solve this now. So see, given dE is x square y double dash plus xy dash minus y is equal to x, and x is positive because you know when you substitute x equal to e power z, then z equal to ln x, so it's defined only for positive values of x. That's why in Euler-Cauchy x is given as positive always. So this can be written as d into d minus 1 plus d minus 1 operating on y is equal to x, where is equal to e power z, let's say, where d is equal to dy dz. So d square minus d plus d, so d square minus 1 operating on y is equal to e power z. This is the equation. Okay, so obviously you have the non-homogeneous part in this equation. So first let's calculate the complementary function, then we'll calculate the particular integral. Okay, So to calculate complementary function, you know, CF y is equal to C1 because m equal to +1 -1 are the roots. So e power z plus e power minus z. So which gives you C1x plus C2 upon x. Okay. So this is the complementary function actually. So how to calculate the particular integral? Pi 1 by d square minus 1 operating on e power z actually. Okay. So if you have e power z, then if you normally if you see e power x, this is nothing but e power x by f of a, provided this denominator is non-zero. Okay. If f of a becomes 0, then yp is nothing but x into e power x by f dash of a. Correct. This is how you calculate the particular integrals for exponential functions actually. Okay. So here clearly when you put d is equal to 1, this becomes 0. So z into 1 by derivative of this 2d operating on e power z. So now if you put the coefficient of z1 here, you just get z e power z upon 2. That's the value. Okay. So yp is equal to z is ln x into e power z is x, so x ln x by 2. So therefore the full solution is sum of complementary function, which is c1x plus c2 by x plus x ln x upon 2. Okay. So this it would be the full solution actually for this given dA. Okay. So c1x plus c2 by x or c2 x inverse plus x ln x by 2, which is option C actually. Okay. That's the correct answer. Okay. In these kind of questions, one advantage is, especially like if they are not asking about the boundary values or something, just the general solutions. In all the options, put c1 equal to 0 and c2 equal to 0. Okay. Then first option gets simplified to y is equal to x cube. Second option gets simplified to y equal to x by 2. This is y is equal to x ln x by 2. Y is equal to 1 by x. Check which of them satisfies this equation. That's all. Okay. Yeah. In previous question, last line. This question, if you see, if you put this system back into this form, this system gives you something like minus 2x1 minus x3 is equal to 0, 2x2 plus x3 is equal to 0, 0 is equal to 2. That's all. Okay. So the last equation is 0 is equal to 2, which is this. So basically don't have any solution. You have taken d square is equal to minus a. D square is not minus a, d square is minus a square, but that's when the function is sine function or the cosine function. Okay. So if you have trigonometric involvement, then you will get, like for example, if you see sine ax plus b or cos ax plus b, let's say. So in this, wherever there is d square, or if you have power more than d square, you will get the d. Shall I show one example for this? How to get the particular integral? It would be clear. Okay. So I'll show you one example maybe. So if you see, like solve d square y by dx square minus 5 dy by dx plus 6y is equal to sine 2x plus 3, let's say, or whatever, sine x plus 4, whatever. Okay. Some function, sine function or cosine function. So in this case, you know, calculating complementary function is simple. Directly you can see this is what you get the complementary function. Okay. Because auxiliary equation is m square minus 5m plus 6 is equal to 0. So m equal to 2 comma 3. So y equal to c1 e power 2x plus c2 e power 3x. Okay. But if you calculate yp, the particular integral value, 1 by d square minus 5d plus 6 operating on sine x plus 4. Okay, so whenever you have sine combination or the cosine combinations, you should replace d square with minus a square, which means replace d square by minus a square, where the function is sine ax plus b. Okay, this is not minus a whole square. Okay, because if it's minus a whole square, I would have straight away written it as a square, but minus of a square, so it's a negative value. Clear? So then if you see 1 by, so a value here, coefficient of x is 1, so d square is minus 1. Okay, so minus of 1 square minus 5d plus 6. You should replace only d square value. Okay, or in fact if you have d cube, okay, for example if you have one more term like d cube plus d square, something like that, in that d cube you can write d cube as d square into d, so you can again replace d square. So wherever there is possibility of taking some d square terms out and substituting minus a square, you should simplify all those terms. Okay, so now this gives you 1 by 6 minus 1 5 minus 5d sine x plus 4 actually here, correct? That's what you get. Then sorry, d square into d, yeah, if you have d cube. Okay, then in that case, so now if you take 5 common, 1 by 1 minus d into sine x plus 4. Okay, now here to simplify this, you don't have any d square term. Okay, if you have d square, you will replace with minus a square and you will simplify, but now there is no d square. So what you do, you go for rationalization. So this can be written as 1 by 5 into 1 plus d by 1 minus d into 1 plus d, 1 minus d square sine x plus 4. So again if you replace this d square with minus a square, this turns out to be 2. So 1 by 10 times 1 plus d operating on sine x plus 4 actually here. So 1 by 10 into 1 into sine x plus 4, so sine x plus 4 plus d of sine x plus 4, and d is derivative with respect to x, so derivative of sine x plus 4 is cos x plus 4. So this full function is the particular integral of this differential equation. Okay, is this clear to all? Okay, now did you understand all the confusions about d square minus a square? So whenever you have the possibility of bringing some d square from any term, you substitute with minus a square. 2016 normal distributions. So a company records heights of all employees. Okay, so let x and y denote the errors in the average height of the male and female employees respectively. Assume that x is normally distributed with mean 0 and variance 4, and y is also normally distributed with mean 0 and variance 9, and they are independent. Obviously they should be independent. Then the distribution z is equal to x plus y by 2 is dash. So what would be the distribution? X plus y by 2. Okay, so normally if you see, a normally distributed random variable, a normally distributed random variable with mean mu and variance sigma square is denoted as x is normally distributed with mean mu x and variance sigma x square. Okay, so this is the general notation of denoting any random variable. If it's normally distributed, you will replace n. If it's some binomial distribution, you write b of mu comma variance, things like this. Okay, so then let's see, here x is normally distributed with 0 comma 4 and y is normally distributed with 0 comma 9. Okay, so then z is defined as half of x plus y. So if z is half of x by 2 plus y by 2. What is the distribution of this z? Okay, so that's what. So you see, distribution of z is also normally distributed. Let's say for z is equal to ax plus by. Okay, so if you have the linear combination, okay, and x and y are independent. X comma y are independent, then you know z is normally distributed with mu x, or you can say a into mu x plus b into mu y. So this would be the mean of the newly generated random variable, and a square variance of x plus b square variance of y plus 2ab into covariance of x comma y. Okay, so what does the term covariance tells you? Covariance tells you that if you change x by some amount, what is the change in y? That's what covariance tells you. But in case of independent random variables, okay, so this covariance term is 0. Clear? Why? Because if things are independent, you change this term do not change. Okay, so that's why this covariance term is 0 if x and y are independent. Being independent. Okay, so then obviously for a equal to half and b equal to half, that's what you get, right? X plus y by 2, then z is normally distributed between, so half into mu x, which is 0, plus half into mu y, which is 0. So this is about the mean. A square, so 1 by 4 into variance of x, so variance of x is 4 actually, plus 1 by 4 into variance of y is 9. Okay, so you can see it's 9, and this term is 0. So clearly this is 1 and this is 2.25. Okay, so 2.25 now, correct. So this is 0. So z is normally distributed from 0 with mean 0 actually, and 1 plus 2.25 is 3.25. That's all. So this is z actually. Okay, so that's how you figure out when you have the functions of bivariate normal distributions. This is how you get the things. Okay. Okay. Fine. Basically these properties are important actually. Okay, normally you might have seen this in your maths classes, but these are certain important properties. Okay, normally I teach in all the descriptive courses in detail, but right now just giving you the formulas. Okay, so 0 comma 3.25 should be the answer. 0 comma 3.25, option B. Okay. Chalo, let's see. Oh sorry, something is missed. One question is missed here. The volume of the solid obtained by revolving the curve y square equal to x square between 0 less than x less than 1 around y axis is dash. Okay, so let's see. Given curve is y square is equal to x, okay, and x less than or equal to 1, you are revolving about y axis. Poisson x and y axis. Okay, then 0 less than x less than 1, so let's say up to here. Fine. So then revolving around y axis, and what is the curve? Y square is equal to x actually. Okay, so if x is positive, or if x is always positive, so y square is equal to x. So something like this. So this is y square is equal to x actually around y axis, and the volume of the solid obtained by evolving the curve y square is equal to x. So y square is equal to x. So then you should consider even this. So this is the curve y square is equal to x. Okay, for between 0 and 1 around the y axis. Now you are evolving this curve about y axis. So let's say if you are revolving this curve, so this is how, maybe I'm not doing very nicely, but I hope you get the essence. Like fine. So this is how you get the volume. Yes, it's around y axis, that's why. So if you evolve about y axis, this is how you get, correct? It's better to watch the revision sessions as of now, okay, because don't spend your too much time in reading the stuff. Okay, so anyway, let's see, this is the case. So clearly this full volume is twice of, let's say, the upper part, for example. Okay, so then if you have this volume, for example, okay, if you are focusing on this volume, can someone tell me total volume is equal to, if you call this V1, so 2 times of V1, which is 2 into, can someone tell me some expression, some nice expression to calculate the volume? Let's say I'll make it simple, x y, okay, and you have some curve, let's say some curve like this, and this is, say, y is equal to a, and this is y is equal to b, and this is some function x is equal to some function of y. Okay, then if you evolve this curve about y axis, what is the volume you would get? Or I'll give you some hint also. Integral a to b something into dy should be there. So what should be this something to calculate the volume? Pi x square dy. X, fantastic. So it should be pi x square dy. Okay, because it need not be cone, it's not a cone actually, in fact. Okay, so if you see pi x square dy, of course this gives you the volume you get when you evolve about the y axis. Okay, like, so therefore total volume is equal to 2 into integral. So when x is going from 0 to 1, if you put x equal to 0, y is also 0, then you put x equal to 1, y should also be 1. So y is changing from 0 to 1, pi x square dy. Okay, so 2 pi integral 0 to 1. So what about x square? You know, y square is equal to x, so x square is y power 4, so y power 4 dy. So this gives you 2 pi by 5, that's all. Okay, so 2 pi by 5 should be the correct answer in this case. So 2 pi by 5, they have given only pi by 5, so I think they intend only for first quadrant. Okay, otherwise if y is equal to, see, 0 less than x less than 1, even here this is also 0 less than x less than 1. Okay, so they should have mentioned, if these are the options, then they should have mentioned it should be in the first quadrant. Okay, maybe that year nobody has challenged this question. Okay, only, so you can write it 2 here for the time being and tick it, but if it's only in the first quadrant, then it's only half of this, which is pi by 5. Okay, you know, I'll tell you one thing, in BRC interview, like almost like 2.5 years or 3 years back almost. Okay, so if you see, they asked me, I have written again one of the favorite subject as maths. Okay, so they told, like, let's see if there is a curve, for example. Okay, if there is a curve, some random curve, and we have given 2 points. Okay, so how do you calculate the length of the curve between the 2 points? That's what they've asked. Okay, this is one of the question actually, because I have written maths as the favorite subject. So if you take one curve, for example, of some shape, of some what is of some shape, yeah. So if I fix 2 points on that curve, how do you get the length of that curve between the 2 points? Okay, so one way, then I asked them immediately, so physically or mathematically you want me to say? Okay, so then they told, first say physically, then go mathematically. Okay, so then I told, obviously physical way is like, if I give you this curve, for example, and I told you to figure out what's the length between these 2 points, A and B. So what you do physically, how you do it, you take one thread. Okay, you put the thread along this curve till point B. Okay, you arrange it smoothly, then you hold the 2 points, make it straight, put it on a scale, you will get the length. Yes, yes or no? Basically you take any thread or string, whatever, you place it along the curve between the 2 points such that it exactly overlaps the curve, then take the thread, make it straight and put it on a scale, you will get the length. This is, you said it in paid batch, acha, maybe. That's one way physically. So mathematically, how do you do this is, so let's say if you have some random curve, which I do it here, something like this. So then first define the coordinate system, okay, to get the length. Okay, 0, x, y, x is equal to b. Okay, so how do you do this is, the first answer I have given is to them, the length is equal to integral a to b square root of 1 plus dy by dx whole square dx. This is what I have given them. Okay, then they told, see, you are a big mathematician. Seriously, this happened in the BRC panel, you know, I got enough embarrassed after this. So once I have written this equation, they told, we are not as sharp as, you know, you in maths, so please explain how did this formula come. Okay, but I know that these guys know much way beyond stuff than me, because they are scientists for so long. Okay, doing maths research, whatever. So then I have to derive this basically. Okay, so it's very simple. Look, let's take a small portion of the curve. Okay, so you take a small portion of the curve, let's say this length is dl, for example. So now you resolve this into dy and dx. Okay, so dy and dx, you resolve it. Then ultimately from Pythagoras theorem, you can see dl square, because these lengths are very small, I can replace the curve with a straight line. So this is dx whole square plus dy whole square. Correct? Will you all agree? Because ideally I'll get something like this. If you zoom in, you will get this is dx and this is dy, but this curve length is very small, so I am approximating it with a straight line. That's all. Okay, so it's a Pythagoras, then definitely this ds or dl whatever is same in both the cases almost, because the length of the curve is very small. Okay, so therefore dl, the small elemental length, is root of dx whole square plus dy whole square. So this is the small elemental length. If you want the full length, you can integrate, and if you simplify this, this is the expression. Okay, you take LCM, root of dx whole square plus dy whole square by dx, this dx gets cancelled, so this complete thing is this. Okay, which is integral a to b dl. That's all. Okay, so that's what I have shown them. Okay, Fine. So this is length of curve. So let's solve this. Let y of x be the solution of the initial value problem dy by dx plus 2xy is equal to x, and initial condition is y of 0 is equal to 0. Find the value of limit x tends to infinity y of x. So solve this question. You know, this is Leibniz linear equation, okay, which you might have done sometimes. Okay, so Leibniz linear equation. So solve this question. Yeah, in BRC they ask you, see, many times I teach you, not many times, 100% out of 100 times, or at least 99% times I teach you from the basic, from the fundamental in all the subjects, because when you stand on the interviews they don't ask you, okay बेटा तुमने अच्छा काम किया था, यहाँ तक आया इंटरव्यू के लिए, अब सिर्फ डिफ्लेक्शन का फॉर्मूला बता के चलिए. No interview goes like this. Okay, they'll expect you, interviews are the actual points where they test you. Okay, otherwise they have already conducted exam, then what's the point of checking you again? Yeah, if you want to eliminate dy, then integrate from point y coordinate of a to y coordinate of b. Okay, like let's say if here in this case, if this is y is equal to c, and let's say this is y is equal to d, this same integral or this integral you can write as integral y equal to c to y equal to d root of 1 plus dx by dy whole square dy. Okay, because both would be same. Correct now? If you take dx square common, you'll get this. If you take dy square common, you'll get what I just said. Okay, you please message me in the Telegram channel. Okay, Harshvardhan, because normally I have never been in SSC JE courses till today, so but I can suggest some people. Okay, I get the concern, so please message me in the Telegram channel, in the Telegram personally. Okay, I'll forward your request, because I've been only in GATE and ESC till today. So yeah, solve this. Either dy or dx will remain after solving. That's the indication, no? See, like for example, if I give you some function y is equal to f of x, okay, and you are doing this, then ultimately this is some function of x, okay, and it's a single variable integration. You solve, you'll get some number. Okay, this is some function, okay, but single variable function. So this is a single variable integration. If you do, you will get some answer. Guys, just a minute, someone is repeatedly doing this. Okay, crash course is efficient. I think you want to ask it sufficient for X exam. Yeah, just do these PYQ sessions, you'll get some benefit definitely. Okay, Indu, did you understand? Dy or dx will not remain. Okay, finally it's a single variable integration and you'll get the answers. You'll get the solution for the single variable integration. Okay, yeah, okay. So what is the answer for this? 0.5. See, it's okay. Did you understand? This is how you calculate the length. Did you understand this formula? How did this formula come up? Yes. Now let's say I've given you some function. So y is equal to sine square x, or sine x, whatever. Okay, I have given some function. So if you differentiate this, you'll get cos x, right? So you put cos x here. Now this is a single variable integration, correct? Yes or no? This value is a single variable integration. Now can we do this? By some technique, when you solve this integration, you will get some number. That's how. If function we know, we don't know the relation between x and y. So how do you justify? But generally, if I give you some function, see, in reality, what we do is, since you have asked this question, I'll tell you. Let's say if I give you a curve, the general, since you have asked a good question, normally in advanced stuff we do this. So let's say I give you some random curve like this, okay? Some random curve I have given you. You don't know this function initially, but just you know the curve, okay? Now what people do is, you take different values on this curve, okay? You don't know the equation as of now, but you take different points on this curve, because you can measure the x coordinate, y coordinate, so you can identify some points, okay? So let's say total n plus 1 points you have identified, okay? So total n plus 1 points you have identified. Now once you apply Lagrange's interpolation or the Newton's interpolation, if you do some interpolating technique, for this n plus 1 points, you can generate a polynomial function of nth degree, correct? Yes? Do you get this? Let's say if you take n to be large, let's say for example some 30 points you have taken, okay, or 31 points you have taken, then you can generate a polynomial of degree 30, and now you know the function which connects all those points. And as you take more and more number of points, you will exactly match the curve, okay? That's how we get the function and we perform this integration. Okay? Is this okay now to all of you? Not only Indu, because she is asking, I was spelling out her name, but did you all understand? Yeah, it's numerical methods obviously. Then in that case, if you don't know the equation, then we get the equation from the data that's available, okay? That's interpolation, of course, okay? So let's solve this. What is the answer you're getting? YFX be the solution of this problem. Yeah, okay. So let's solve this question. Given dy by dx plus 2x operating on y is equal to x, and y of 0 is equal to 0, of course, okay? So we have this. Plenty of techniques again to solve this question. So let's see. First is one technique is Leibniz linear equation. So integrating factor is equal to e power integral 2x dx. So e power x square is the integrating factor. So solution is y into e power x square integral x into this integrating factor e power x square dx plus some constant, okay? Then if you adjust a 2, 1 by 2 and a 2, then y into e power x square is equal to half into this complete integration of this function is again e power x square plus some constant. So y is equal to half plus constant e power minus x square. Okay, so whatever is the constant c, so at y equal to 0, x is equal to 0, so c is some positive constant whatever, but as x tends to infinity, so after x is very large, okay, so as this x moves to infinity, can someone tell me what is the value of y tend to? 1 by 2. Okay, so because if x is becoming very large, then this term keeps coming to be 0 irrespective of this finite constant. Okay, so this term would be 0, so y equal to half, so y tends to half, which is equal to 0.5. Okay, if this question comes in exam again, I'll solve it only in 2 seconds or maximum 5 seconds. Do you know how? If this question, can you believe that this question can be solved in 5 seconds? Any one of you? Even if you separate into variables, you'll still take some time to integrate, correct? But will any one of you believe if I say that this question can be solved in 5 seconds? No, right? Look, I'll solve the same question using some different technique. Look, let's, for example, for your understanding, write this in terms of t. So dy by dt plus 2t y is equal to t, and y of 0 is equal to 0, because you can replace the variable with t, whatever you can understand. When t tends to infinity, okay, t tends to infinity, okay, when time t is tending to infinity, which means the system reaches steady state, yes or no? Correct. Initially this differential equation gives you the change of y with respect to time t. Now as time t is tending to infinity, the system reaches steady state, correct? Yes. Can you again? Right now the dE whatever is there is giving you some change of quantity y with time t, okay, but as your time t goes to infinity, this rate of change of quantity y will be 0, the system reaches a steady state, okay, which means what is the value of this term then? At steady state, what is this value? Any one of you? 0. So at steady state, that's all. Okay, clear? After some long time, okay, so the rate of change in quantity y is not changing, so it's 0, so definitely at that function the function stabilizes to y equal to half. Got it? Which you will eventually observe when you keep solving this using all the integration techniques. Yeah. Okay, so let's solve this question from sequence and series now. Okay, so I'll tell you one technique today. In tomorrow's class, guys, I'll tell you some. This is the last question for today, but in tomorrow's class, I'll solve questions on partial differential equations, more questions like solving wave equation, heat equation. GATE 2024 also there's a question on in 2023 in fact. Okay, so there's a question on heat equation. Okay, solution of heat equation, which is basically the diffusion equation actually. So we will solve in tomorrow's class, especially we'll see the D'Alembert solution of wave equations, which is very important again for XE, then solution of heat equation, analytic functions in complex variable involving some complicated functions, not simple functions. Like tomorrow's class is like the segregation of all the, I won't say tough, but some in-depth topics. Okay, that's what. Fine. Now let's see. For the series n equal to 1 to infinity x plus 1 whole power n by n into 2 power n minus infinity less than x less than infinity, which of the following statements is not correct? Okay, So you want which statement is not correct. 19 XE 1 mark question, of course, luckily. So let's see. This is what you get. Okay. Now what we do something called the ratio test. Okay. So if you do the ratio test, D'Alembert's ratio test, so this is the nth term actually. Okay. So when you have the nth term, this series is normally denoted as un. Okay. So this is the nth term in the series summation. Okay. So D'Alembert's ratio test tells you as you go to infinity, the modulus of un plus 1 by un, this should be less than 1 for convergence. So this has to be the function for the convergence. Okay. And normally this majority of the questions, I would say almost all the questions in the last 7-8 years are on the D'Alembert's ratio test. Okay. So this is the criterion for convergence of this function. So if you see, therefore limit n tends to infinity un plus 1. So if this is un, what would be un plus 1? Mod x plus 1 whole power n plus 1 by n plus 1 into 2 power n plus 1 into n 2 power n by x plus 1 whole power n. So this value should be less than 1, correct? Because if that term, this full term is un, then un plus 1 by un would be this term, because you just divide it here, then you get it this way. Okay. So then this gives you, this is 2. Okay. Limit n tends to infinity x plus 1. So mod n by 2 times of n plus 1 into x plus 1 should be less than 1, of course. Okay. So then this x plus 1 and 2 are out, because this limit depends only on n, and x and 2 are different things. Okay. So if you see, mod x plus 1 by 2 into limit n tends to infinity mod n by n plus 1 less than or equal to 1. Can someone tell me what should be the value of this limit? And n is positive, of course, n is tending to infinity, so you may delete this modulus. So limit n tends to infinity n by n plus 1. So what's the value? One, correct? Because you can see if you take a n common, 1 by 1 plus 1 by n, so when you put n equal to infinity, this becomes 1. Okay. Also you can see like 1,99,999 by 2 lakh. If you write this value tends to 1. Okay. So that's simple logic. So this limit tends to 1. Okay. So this tells you mod x plus 1 should be less than 2. This is the criteria for convergence. Criteria for convergence. Okay. So this gives you minus 2 less than x plus 1 less than 2. So minus 3 less than x less than 1 actually here. So if the series has to converge, then minus 3 less than x less than 1 actually here in this case. Okay. So let's look at the options. Then the series converges at x equal to minus 3. Okay. So if you see, this is minus 3. The series converges at x equal to minus 1. Which of the following options is not correct? No, sorry guys, here you should have this things. Something is catchy. Just a second. Sigma n equal to 1 to infinity x plus 1 whole power n by n 2 power n plus 1 2 power n plus 2. So mod x plus 1 by 2 should be less than 1. So mod x plus 1 is less than 2. So minus 2 less than x plus 1 less than 2. So minus 3 less than x less than 1 actually here. So definitely series converges for these two, no issue. Okay, it converges for minus 1 and minus 1 and 0. So these two doesn't have any issues. You can delete this. These are not the correct choices. Okay. Then at x equal to 1, what's happening? Let's see. At x equal to minus 3 and x equal to 1. Let's see. At x equal to 1, first of all, at x is equal to 1, the series n equal to 1 to infinity. So if you put n equal to 1, sorry, x equal to 1, this becomes 1 plus 1, 2 power n. So 2 power n by 2 into, sorry, by n into 2 power n. This would be the series actually. Okay. So which is summation n equal to 1 to infinity 1 by n. Now can someone tell me what happens to the series at this point? Like if you take this series of 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on, can someone tell me what does this series? Will this series converge or diverge? It diverges. Okay, so this series will diverge actually, which can be shown generally in the ratio test, of course. So this diverges. Clear? So you can see when it diverges, then the series converges at x equal to 1 is a wrong option. So this is wrong. So this is the correct choice, because which of the following is not correct? The series converges at x equal to minus 3. This becomes minus 1 by n. So it fluctuates, but it converges. Okay. So this also can't be taken as correct choice. But at x equal to minus 1, sorry, at x equal to plus 1, this series actually diverge. Okay. It's not a finite value in this case. You may think that this value is as you go, like the value is decreasing. Okay. But the series diverges actually. Like you can see, we can easily show that the series diverges. So if you see, this 1 is definitely greater than 1 by 2, correct? Similarly, this 1 by 2 is greater than 1 by 4. This 1 by 3 is also greater than 1 by 4. Okay. Similarly, this 1 by 4 is greater than 1 by 8. This is greater than 1 by 8. 1 by 6 is greater than 1 by 8. 1 by 7 is also greater than 1 by 8. Okay. So if you do this things, how to find that is diverged? I'm showing you. That's what. Okay. So this is half, plus this is again half, plus this is again half. So likewise, if you look for the next 1, 2, 4, 8 terms, again you'll get half. So likewise, if you form pairs of 1, 2, 4, 8, 16 terms, you'll keep getting the terms which are more than half. Understood? So infinite times of half is infinite. Okay. That's why the series diverges actually. Clear? If this series itself is diverging and here every term is greater than the corresponding term, so this series will also diverge definitely. Okay. You can also show in a simple way using integral test, but this is the simplest technique to show that this series diverges actually. Understood? If summation of all these terms itself is diverging, then this series will definitely diverge, correct? Because 1 is greater than half. This 2 combinations is greater than this combination. So each and every term is large, is big. Okay. So that's how you find out. Clear? So this is the D'Alembert's ratio test basically, which gives you a very good understanding. Clear? So we'll stop here for today. Anyway, in tomorrow's class, I'll put questions on, if you put minus 3 in the function, it fluctuates, okay, but it is bounded, definitely. It not diverges. It oscillates, that's all. In fact, it can converge also. It converges, yeah. Like you can see, you'll have 1 minus 1 by 2 plus 1 by 3 and all. What is integral test? Integral test actually tells you, like, if you have the series, okay, the series of summations, Have you seen writing summation as integration anytime? So it's a direct test basically to show whether a given sequence will converge or not. Like for example, if you see 1 by x power p, this can be written as integral x power 1 by x power p dx. Okay, that's what you get. Divergent is the value goes to infinity. Okay, the value of the expression, if you calculate, that will go to infinite. Okay, like if you sum up all the terms till infinity, this answer would go to infinity. Okay, z plus 2 whole power n by n factorial, same, you can apply this convergence test. Okay, like if you see, if you apply D'Alembert's test, ratio test, z power z plus 2 whole power n, so z plus 2 whole power n plus 1 by n plus 1 factorial into n factorial by z plus 2 whole power n, this modulus should be less than 1. N factorial can cancel this n plus 1 times, so mod z plus 2 into limit n tends to infinity 1 by n plus 1, this value should be less than 1, but clearly you know this is 0 always, so this converges over the complete plane. Okay, for any value of z that says converges. Okay, because this inequality is true for any value of z irrespective of the z, irrespective of the z value, it converges. Okay, so this is like summation z plus 2 whole power n by n factorial converges for all values. Okay, it's okay. Vibhu, divergence is basically the value is won't be finite, it won't be finite value. Okay, so the value goes to infinity. Got it? Yeah. So tomorrow is one last class for maths, of course, and again I think Sandeep sir will have one more session tomorrow, and I myself will take XE maths again for one PYQs. In tomorrow's class, we'll look at a deeper sense of. So should I cover yours 2024 𝐂𝐤𝐬𝐿? Yeah, okay, it's good. Okay, then I'll do integral test questions at least. Then we'll solve partial differential equations, wave and heat solution questions. These are important again. And then diagonalization we have covered, basic matrices, eigenvalues, all this stuff, calculus, complex functions in analytic functions, some complicated functions would come. I'll talk about that. Then interpolation, normal distributions, probability, Simpson's 1/3 rules, Euler's methods. Okay, so fine. Anyway, I'll try to keep questions from all the topics which are not discussed today. Okay, so that you would get some good practice. And definitely, I'm telling you guys, after you write exam, these sessions will definitely play a big role. I told last year, I'm telling you now, evil. Okay, fine. So first, and this is the Telegram channel. If some of you want to join there, you can keep moving the things. So basically, tomorrow we have the Sandeep sir session, fluid mechanics at 2 to 5 p.m. and tomorrow I'll try to take the session at 7 p.m. okay, because today there is some clash on the channel, so that's why I was not able to do, but 7 to 10 hopefully we'll do tomorrow. Okay, if there is any postponement, I'll update you. Okay, in the Telegram channel, this Telegram channel. Okay, yeah, so thank you. Then we'll meet tomorrow. Okay, hopefully at 7 p.m. if it delays, then I'll inform you. Are you all understanding things? Okay, because many of you might have seen only teaching fluid mechanics, or some of you might have seen me only teaching thermodynamics, all this stuff, but I teach maths as well. Okay, fine. Yeah, good night all. No Abhyas session for maths, hai na? You can see this is the Abhyas for maths, both the Abhyas sessions. Okay, and I myself will take. मिल सकता है हसीन, कोई दिक्कत नहीं. ओके, 64 मार्क्स पे लगभग रैंक आते हैं कि 500 से नीचे, सो पक्का मिलेगा. एक्सएमएस देखने से डर लग क्यों? डोंट वरी आदित्य, जस्ट स्टे काम एंड ट्राई टू सॉल्व. ओके, यू विल गेट द आंसर्स. ठीक है, सो गुड नाइट, विल मीट टुमारो टेंटेटिवली एट 7 p.m. but if there is change I'll update. Okay, yeah, पहले गेट एग्जाम होने दो, then I'll guide you for BRC. Okay, yeah, good night all of you, take care.